Hello guys, thank you for watching our presentation. My name is Professor Eduardo Godoy. I'm an associate professor at the São Paulo State University in Brazil, and I will present the paper Proposal of a Hybrid LoRa Mesh LoRaWAN Network. This paper is a research collaboration between the São Paulo State University and the University of Brescia in Italy. So, the summary of our presentation, I will talk about the introduction and the concepts. I will talk about the hybrid LoRa mesh and LoRaWAN, the description of the proposal, and about the integration of the LoRa mesh in the LoRaWAN. I will talk about the development of the LoRa mesh, that is the focus of the paper, the hardware used, and also the routing protocol. We'll present some experimental results of the LoRa mesh, the validation of the time analysis, and I will finally talk about the conclusions of the paper. In the first part of the paper, I will talk about the introduction, I will talk about the context of the paper, the LoRaWAN architecture, and also the goals of the paper. For Internet of Things solutions, we need to transmit data at great distances, and we need to interconnect many different sensors and actuators for the decision making. We have many different wireless protocols available to do that. Among them, we can talk about the low power area networks, the LP ones, which can improve this scenario of communicating with long distance because of the low cost of the devices and also because of the long range communication. When considering the LP ones, we have several types of protocols available, such as the LoRaWAN, the Sigfox, and also the narrowband IoT. The LoRaWAN is one of the most widely diffused and adopted LP1, and also LoRaWAN does not use cellular networks for transmission. So in this paper, we have chosen to use the LoRaWAN LP1. Considering the LoRaWAN architecture and protocol, we can see the main components of the LoRaWAN network in the picture. We can see the end devices, which are the sensors and actuators. We can see the gateways that connect the information from the end device, and we can see the network server and application server. Considering the LoRaWAN protocol, we have a long-range communication protocol with low energy consumption. We have a star of stars topology, in which we can see a one-hop topology between the end nodes and the gateway, and also a one-hop topology between the gateway and the servers. We have a chip spread spectrum with 3 different classes of devices, and we also have security mechanisms such as network keys and device keys for security communication. A problem that we have in this type of architecture is that we have coverage or shadow areas inside the LoRaWAN coverage because of the obstacles and topography. And this is one of the things that we want to improve with our proposal. So the goals of our paper is to propose a hybrid solution exploiting both the mesh architecture with LoRa communication with the advantage of the well-established IoT infrastructure of LoRaWAN. And doing that, we want to improve shadow areas coverage inside the LoRaWAN and also extending the LoRaWAN coverage itself. In the second part of the presentation, we'll talk about the hybrid LoRa mesh LoRaWAN. We'll discuss the proposal in details, and I will talk about the integration of the LoRa mesh in the LoRaWAN. In our proposal, we can see in the picture, we want to add a LoRa mesh network to the LoRaWAN, maintaining the LoRaWAN capabilities at the proxy node, connecting the LoRa mesh to the gateway. So we have the LoRaWAN network, and we have the end nodes. One of the end nodes is the proxy node, and we want to add a new LoRa mesh coverage in order to improve the shadow areas coverage that we can see in gray in the picture. So the main characteristics of our proposal, well, we have to few nodes or few hops inside the LoRa mesh because the LoRa communication is already a long-range communication. We have nodes, the LoRa mesh nodes with unique identifiers and security keys. We have a compatible LoRaWAN node. So the proxy node is the coordinator of the mesh and is also a compatible LoRaWAN node. And the LoRa mesh improves LoRaWAN coverage in shadow areas, such as I explained before. So considering the integration of the LoRa mesh in the LoRaWAN, we are proposing the use of the proxy node. So the proxy node is the coordinator of the LoRa mesh and maps every mesh node to a virtual LoRaWAN node. Each LoRa mesh is loaded with his own unique numbers, the device address, and also the application key. Each LoRa mesh node has an encryption used to cipher the answer to specific requests of the LoRa node. For the uplink of data, the LoRa mesh node creates the MAC payload and ciphers it using the encryption function and also his unique keys, and send that information to the proxy node that's sent to the LoRaWAN. And for the downlink of data, the proxy node extracts the MAC payload from the received LoRaWAN message and forwards this data to the specific LoRa mesh nodes. In the third part of this presentation, I will talk about the development of the LoRa mesh. I will talk about the hardware used, and I will talk about the routing protocol that we implemented. So for the development of the LoRa mesh, we are using the Heltec Wi-Fi LoRa 32, the version 2 of this board that is shown in the picture. It is a development model with a 32 system on chip, the S32 from Espressif, with internal memory, with an OLED display, and also a LoRa transceiver. We have connectivity for Wi-Fi, Bluetooth Low Energy, and LoRa. And we also have a connection for external LoRa antenna. Okay. For the paper, we have connected a DHT11 sensor for measuring temperature and humidity to this module with a 2.5 dBi antenna and a battery for mobility. And only the proxy node does not have the sensor, and it is using an external antenna. Okay. For the LoRa mesh development, we had to implement a routing protocol to create a route for communication between the devices in the LoRa mesh network. We have chosen the AODV protocol because of its simplicity and because it fits the proposal needs. It is a simplified AODV because we have implemented some features of the AODV protocol. We have used the route request and route reply signaling. We have implemented the route cost calculation, the route lifetime, and also the route table update on demand. Okay. In the fourth part of the presentation, we'll talk about the experimental results with the LoRa mesh. I will talk about the creation of the network and its validation, also the timing analysis. In order to verify the development of the LoRa mesh, in the first part we have created a network in our campus. So we have used 5 nodes with up to 3 hops of communication. So we can see in the picture that the flow of the data using the arrow. So from the communication from node B4 to the proxy node, we have three hops. Okay. In order to validate the development of the LoRa mesh, we used the debug messages from the nodes in the network. So in the first part, we could verify the routing creation mechanism or the creation of routes and the mesh communication among the nodes. Okay, and we could see the routing calculation, which is calculating the costs of in choosing the best route for communication. And also we have made tests with rerouting or the creation of a new route after turning off an active node of the mesh. So we had a route for communication, and we turned off the modules inside this route, and we forced the mesh network to create a new route to communicate from these devices to the proxy, okay? So we could verify each one of these steps using the debug of messages with the network operation. During the LoRa mesh operation, we also made the timing analysis. We calculated the route creation times and the average communication times from the LoRa mesh nodes to the proxy node. For these calculations, we used the timestamps of the debugging messages. And as you can see in the table, we had a route creation time of 15 seconds for the creation of routes to all nodes, all LoRa mesh nodes. And we also have transmission times from the LoRa mesh nodes to the proxy nodes, which are of course related to the considering route and also the number of hops, okay? And it goes from 1.5 to 7.5, which is proper to the LoRa mesh operation. In the final part of our presentation, I will talk about the conclusions of the paper, the future work, and I will leave my content for future interactions. So, as conclusions of our paper, we had that the proposed hybrid LoRa mesh LoRaWAN network can in fact improve LoRaWAN shadow areas coverage and also can extend communication coverage of LoRaWAN networks. The simplified AODV routing protocol shown an adequate performance, adequate operation for the LoRa mesh proposed in this paper, that is with a small number of nodes and up to 3 hops, okay? Experimental tests validated the LoRa mesh deployment, and also a proposal for the LoRa mesh integration with the LoRaWAN was discussed in details. As future work, we are working on the integration of the LoRa mesh with the LoRaWAN, as described in the paper. We are focused on the compatibility and security concerns. And if you have any question regarding our presentation or regarding our paper, please contact me, okay? Feel free to contact me. You can see my email on the screen, okay? Let me know if you have any questions. Thank you very much for watching our presentation.